Hi everyone, so in this video we're going to be capping off the tangents and normals unit of or section of differentiation, and we're going to be going through some practice problems. So there aren't actually any in the three examples that I'm going to show that relate to external points because they're hard to find in actual exams. All the questions have been pulled from actual AddMath exams. So there are only tangents and normals questions here. However, it's good to know the external points, like the way you approach those questions. So let's start with this one. The curve with equation y equals x cubed plus 2x squared minus 7x plus 2 passes through the point negative 2, 16. So to find the equation of the tangent to the curve at the point A, which is this point over here, which is negative 2, 16. Okay, first thing we do is differentiate the function when we're given this kind of problem. So dy over dx is 3x squared plus 4x minus 7. And then we have to plug in the x value of the point into the differentiated function to get our gradient, as we've seen in the previous video. So that gives us 3 times negative 2 squared plus 4 times negative 2 minus 7, which is equal to 12 minus 8 minus 7, which is negative 3. So our gradient is negative 3. Now we just use substitution to find the y-intercept value. So y is equal to negative 3x plus c, we know. So substituting y in, so 16 is equal to, then we do negative 3 times negative 2, which is just 6, plus c. So c has to be 10. So the equation of our tangent is y is equal to negative 3x plus 10. So we've done actually all the differentiation we need. The next question actually does not involve differentiation, but it's good to do because we actually see tangents and normals typically in AddMath papers that are in a larger context, and we need to be able to apply that. So we have to find the coordinates of the point where the tangent meets the curve again. So what we have to do is actually equate the tangent with the actual curve, because then we'll see the two distinct points that they meet. So let's do that right now. X cubed, oops, I'll write that better. X cubed plus 2x squared minus 7x plus 2 is equal to negative 3x plus 10. Which means we can bring everything to one side to make it x cubed plus 2x squared minus 4x minus 12. Sorry, not minus 12, minus 8. And we can actually write this as x plus 2, x squared plus bx minus 4. And the reason being that we already have this point over here, which means that in our factor, in our polynomial, we have to have negative 2 represented. So we have x plus 2, and if we substitute negative 2 in here, it becomes 0 automatically. Now, the way we can actually approach this, while we would usually need to use some polynomial work, we can actually tell that this polynomial does not have a middle term over here. And the way I can say this is because when you look at this polynomial, we can actually write it as this because x times x squared is the only thing that can make x cubed in this case. So the coefficient of x squared over here is 1. And 2 times negative 4, the only thing that can make negative 8. That's why I've been easily able to write this. But we can actually reasonably infer that there is no bx over here. Because let's say b was 0. Then it'd be x plus 2, x squared minus 4. And this is factorable. We can write this as x plus 2, x plus 2, x minus 2. Since x plus 2 times x minus 2 is x squared minus 4. Because it's the difference of two squares. And this gives us two distinct roots. It does not give us more than 2 roots. So the two roots are when x is equal to negative 2 and when x is 2. So we can reasonably infer that the other point has an x coordinate of 2. So let's say the other point is b. We can say it's 2 and then it's y. We need to find the y value now. The easiest way of finding the y value is just sticking it into our tangent equation. So y is equal to negative 3, and then we multiply by 2 because we're substituting 2 in there, plus 10, which means that y is equal to negative 6 plus 10. So y is equal to 4. So we can say that b is 2, 4, and that's the other point of where the tangent meets the curve again. Okay, so the next problem we're going to solve is related to normals. So we have to find the equation of the normals to the curve y equals x times x squared minus 12 to the power of a third at the point on the curve where x is equal to 2. So we do the first two steps normally. So dy over dx, we have to find the derivative. Is equal to, so we can use product rule because there are two values of x that are being multiplied by each other. So let's first differentiate this and leave the other part untouched. That would just become x squared minus 12 to the power of a third. And then we add that to the differential of this part multiplied by just x. So we can write that as x times, and we use a square bracket here because it would be a pretty big expression, 1 over 3 times x squared minus 12 to the power of negative 2 over 3. And that's going to be multiplied by 2x because we differentiate the inside part. But that's just a very quick version of chain rule. You can use the long version of chain rule to do so. And we don't actually need to simplify this because we can just substitute x equals 2 in there. It'll save us a lot of trouble along the way. So when x is equal to 2, dy over dx is equal to 2 squared minus 12, which is negative 8. Negative 8 to the power of a third is negative 2. And we add that to 2 times 1 over 3 times negative 8 to the power of 2 over 3, which is multiplied by 4. So essentially, we have negative 2 plus 2 times, and then negative 8 to the power of 2 over 3 is 1 over 4. So 1 over 4 times 4 is 1, and 1 times 1 over 3 is just 1. And this overall simplifies to negative 4 over 3. But since we're relating to normals, we have to do the negative reciprocal of that, which is 3 over 4. So our gradient is 3 over 4. Now we just need to find the y value because we're only given the x value of the coordinate. So y value is equal to, we just substitute it into the normal curve equation. It's just 2 times negative 8 to the power of a third, which is 2 times negative 2, which is negative 4. And now we can use the standard normal equation. So y is equal to 3 over 4x plus c. Substitute y and x in there. Negative 4 is equal to 3 over 2 plus c. So c is equal to negative 4 minus 3 over 2, which is equal to negative 11 over 2. So our final equation is y is equal to 3 over 2x. Sorry, not 3 over 2x, 3 over 4x. Minus 11 over 2. So let's do one more problem before we wrap up this video. So here's our final problem of the video. Find the equation of the normal to the curve y equals ln 2x squared minus 7 at the point where the curve crosses the positive x-axis. Give your answer in the form ax plus by plus c is equal to 0, where a, b, and c are integers. First thing we have to realize is that we aren't given a point over here. We're just told to find it at the point where the curve crosses the positive x-axis. But what does that mean? Well, if you think about a normal xy plane, xy, then you'll see the positive x-axis is the part to the right that's on the x-axis over here. So to find this, we just need to find the value which makes y equal to 0 because it's on the x-axis. So when y is 0, we actually have to generate ln 1 because ln 1 is 0. And we have ln in here. So ln 2x squared minus 7 should be equal to 1. Sorry, ln 1. Which means that 2x squared minus 7 is equal to 1. And 2x squared is equal to 8. Which means x squared is equal to 4. The reason they've said positive x-axis is because there are two solutions. One is positive and one's negative. Because when we do x is equal to root 4, it could be plus or minus root 4. So in this case, because it's positive, we have to go with x is equal to 2. So the point is x equals 2. And obviously, the y-coordinate is 0 at this instant. So now we have enough information. We've got our coordinate, which is 2, 0. And we've got our curve. And now we just need to differentiate. So dy over dx is equal to, and we remember how we differentiate ln. The differentiated part on top divided by the part in the bracket. So differentiated, it's 4x, and we divide it by 2x squared minus 7. because if we have ln of f of x, that's the differentiated version of f of x over f of x. That's how you differentiate it. So now that we've done that, what we can do is we can substitute our value of x in here to get our gradient. So m is equal to 4 times 2 is 8. Then 2 times 2 squared is 8 minus 7, which is just 1, so it's equal to 8. However, our gradient's 8 only for a tangent, so that means that since it's a normal, our gradient is the negative reciprocal of 8, which is negative 1 over 8. So our gradient's actually negative 1 over 8. Now we just use the standard normal equation, y equal to negative 1 over 8 x plus c, and we substitute y and x in there. So y is equal to 0, and negative 1 over 8 times 2 is equal to negative 1 over 4 plus c. So c is equal to positive 1 over 4. So our equation here is y is equal to negative 1 over 8x plus 1 over 4. But they want us to structure in this form, which means we need to make sure that none of them are fractions. So let's multiply everything by the fraction, let's multiply everything by 8 to get rid of all the fractions. So 8y is equal to negative x plus 2. Now we bring everything to one side, where we get x plus 8y minus 2 is equal to 0. And that's the way they want us to write it. So that's it for this video. I hope you guys have got a good grasp of tangents and normals. And hopefully in the near future, after some more practice if you need it, you'll be able to look at these problems and think, yeah, this is a normal problem, if you catch my drift. Anyway, thanks so much for watching, and see you in the next video, and hopefully you understood my pun. It was pretty simple and a lame pun, but bye.